Sometimes we're given a triangle that is not a right triangle, but we do know some information about it. For example, maybe we know this angle measure here, and we know this side length here, and maybe we're given another angle here that we know. And we want to try and solve this triangle. We want to try and find the other angle measures and the other side lengths. But we don't right now have a means of doing that because, again, this is not a right triangle. So what do we use? Well, there are a couple of things that we can use. And in this particular case, we'd use something called the law of sines. And in order to use the law of sines in our triangle, we need to be given something called an angle side pair. So if we were to label this triangle, let's say it's A, B, C. An angle side pair is just when you're given an angle, let's say angle A, and the side length opposite it. So we know angle measure A, and we also know side A. So we're given this angle side pair, so we can use law of sines. So there are different types of triangles that we would use the law of sines for. And let's take a look at which ones we would use. So these are the three different types of triangles that you would potentially be looking at when you're using the law of sines. So we can see for this one, we're given two sides and a non-included angle. And we have an angle side pair here. So we are given angle measure C, and we're given the side length of C. So we have this angle side pair. And so this type of triangle we classify as a side-side angle triangle. So side-side angle triangles, if you're given two sides and their non-included angle, we can use law of sines. For this one, we're given two angles and the non-included side. But again, we have angle measure C and we have side C. So we have an angle side pair here. So we can use law of sines. We classify this type of triangle as an angle side triangle. Two angles and the non-included side. Now this last one is an angle side angle triangle, and because we're given two angles and the included side. Now it might be kind of hard to see. It doesn't look like we have an it doesn't look like we have an angle side pair because we don't know this measure and we are only given side length C. But we can actually find this measure. This measure here can easily be found because we know that all of the angles of a triangle sum to be 180. And since we're given two angle measures, we can find the third easily by just subtracting their sum from 180. So we do in fact have an angle side pair. It's just we have to do a little extra work to find it. So in order to use the law of sines, we need to be given one of these three types of triangles: a side-side angle triangle, an angle side triangle, or an angle side angle triangle. What does the law of sines say? So the law of sines says if you're given triangle ABC with side lengths A, B, and C, right, where side A is opposite angle A, B is opposite B, and C is opposite C, that this proportion holds. So basically what it's saying is the ratio between the sine of an angle measure and the side opposite it will be equal for all three sides. So the sine of angle A divided by the length of side A is going to be equal to the sine of angle B divided by the length of side B is equal to the sine of angle C divided by the length of side C. And that's the law of sines. The law of sines also holds true if we're looking at it in terms of its reciprocals. So if we had A over the sine of angle A equals side B over the sine of angle B equals C over the sine of angle C. This is also true. It kind of just depends on the situation as to which one you want to use, but both hold true because we know that if we have a proportion, we can take its reciprocal and it still holds its equivalence.